Okay, so in this video, we'll talk about how pressure control works. We don't use a lot of pressure control, but understanding pressure control first will make understanding PRVC a lot easier, and in PRVC is used quite a bit. Okay, so with pressure control, first of all, as you might imagine, you set an inspiratory pressure, maybe something like 20 centimeters of water. And in this mode, you set an inspiratory time. You actually say how long you want inspiration to go on for. So maybe something like 0.8 seconds. Sometimes we'll use more, sometimes we'll use less. There can be reasons to change it, but something like 0.8 seconds might be pretty typical. Once again, you'll set an FiO2. And once again, you'll set a PEEP, maybe 5. You do not set a flow. Flow will depend upon what's going on with the lungs and what pressures you set and what's going on with the patient's inspiratory muscles or expiratory muscles, what they're doing or not doing. But you don't set the flow. And what happens here, again, we'll trace kind of pressure and flow. Set up our zero flow there. Set up our representative alveolus. If we have a PEEP set at 5, then 5 centimeters of water here. The end of a breath, the end of expiration, the expiratory valve is open. Presumably the PEEP is 5. Airway pressure here is 5. So as we're tracing it, it's going to be 5, and there's going to be no flow. And then once again, the patient will have to, I'm sorry, I didn't say this. You're going to set a rate too. Maybe something like 15 breaths per minute. Okay, and in this case, if the patient makes an inspiratory effort, drops their airway pressure, once again, we'll say that the patient is set on a pressure trigger at 2, meaning that if you can get the pressure here down to 3, 2 less than the set PEEP of 5, if the patient can drop their airway pressure enough to get the pressure here to 3, then the ventilator is going to say, okay, patient wants a breath, let's give a breath. So once again, we'll see a little drop in the airway pressure here. And then as we switch into inspiration, this valve will open, this valve will close, and the ventilator will put in the pressure that we told it to put in. Now we set the inspiratory pressure at 20, but we also have to account for the PEEP. That's going to be an additional pressure. So the ventilator is going to try to put in a pressure of 25 here. And as we do that, we've got a pressure of 25 here. Presumably the airway alveolar pressure might have been something like 2 when this became 3. So we've got a pressure gradient of 25 to 2, so we're going to have flow go in. Initially quite a bit of flow as airway pressure goes to 25. And again, if we're measuring pressure here at the Y, what the ventilator is going to try to do is, even as things change, the ventilator is going to try to maintain enough pressure to keep the pressure here at 25. As the breath, as air goes on, as air gets pushed in, as the inspiration goes on, alveolar pressure is going to rise. Maybe this will get up to something like 10. As alveolar pressure starts to rise, flow will start to decrease. Let some more air in. This continues to go up and up. Maybe it gets up to something like 15. Flow is decreasing. I think you can appreciate that if we let this go on forever, eventually the alveolar pressure is going to get all the way to 25 and there'll be no flow because the two pressures are equal. But we don't let it go on forever. We decide how long it goes on for, and we usually let it go on for something like 0.8 seconds. So at that point, when we're at 0.8 here, maybe the alveolar pressure, let's just say, is 18. You still have a gradient, so you still have some flow, but by that point, flow is slowed down quite a bit. And then once we get to that 0.8 second mark, then we simply switch over. The inspiratory valve closes, the expiratory valve opens. Now we've got a pressure gradient of 18 to 5. So in this case, once again, of course, we have expiratory flow. As this empties, flow starts to decrease. Airway pressure comes back close to 5 at the Y. And again, all things being fairly normal, alveolar pressure will get all the way back to 5, and there'll be no flow again before the next breath. How big did the breath get? Well, that's just going to depend, right? Depends a little bit on how much pressure you told it to put in. It's going to depend a little bit on how long of an inspiratory time you gave it. It's going to depend a little bit on what the patient's inspiratory muscles are doing. If the patient's inspiratory muscles continue to contract, then you maintain a big pressure gradient, and the bigger the pressure gradient you maintain, all things being equal, the bigger the faster the flow and the larger tidal volumes you'll get to. So you don't have control over the tidal volume, but you do have control over the airway pressures, and you can adjust them to try to get the tidal volume that you want. So that's pressure control. In our next video, we'll talk about a little bit more sophisticated, or a little bit more complicated mode of ventilation called pressure regulated volume control. It goes by a number of different names with different ventilators. For instance, the Puritan Bennetts at our hospital use something called VC+, but these have become fairly popular modes in the last number of years, and we'll talk about how those work.